In this how-to video, we'll review slope-intercept form equation of a line, how to identify slope and y-intercept, and then how to graph a line using slope-intercept form. If you want to specifically see one of these three things, turn to that slide and press play. Otherwise, watch all 4 slides. So slope-intercept form is simply one way to write an equation of a line. Other forms include standard form and point-slope form. The thing that differentiates slope-intercept form is that y is isolated. The general version of slope-intercept form is y equals mx plus b. The reason slope-intercept form is significant and useful is because when a line is in slope-intercept form and y is isolated, you can always easily identify the slope, which we know is m, and b, which is the y-intercept. The slope is always the number that's multiplying x. It's always the coefficient of x. And the y-intercept is always the number that's being added or subtracted. We'll talk mathematically why when we get to this example, but for right now, all you need to know is that as long as y is isolated, it's in slope-intercept form. Once in slope-intercept form, you can pick out the slope and the y-intercept. So in this example right here, since y is already isolated, it's already in slope-intercept form, so I can first identify the slope by looking at the coefficient of x, which is just 3. When stating the slope, you just say the number, don't say the variable along with it. Now I can also identify the y-intercept, which I'm using the variable b, and since we talked about up here that it's the number being added or subtracted, in this case it's going to be 4. So the mathematical reason behind that, if you remember, if you can picture this as your y-axis, remember the y-intercept is the place where the line touches the y-axis, and in order for that to happen, the x-coordinate has to be 0. So to find the y-intercept, you would change x to 0, and the number that would pop out would be just 4, because 3 times 0 would go away. So the y-intercept would be 4, but we use b to stand for that. X and y are all those infinite ordered pairs that make up a line. On this example over here, if my goal is to identify the slope and the y-intercept, I can't do that yet because it's not in slope-intercept form. The reason we know that it's not is because y is not isolated. So the first objective would be to isolate y using reverse PEMDAS. So first I'm going to get rid of my 4x, and I'm left with negative 2y equals 8 minus 4x. Y is not isolated yet, so I'm still going to divide by negative 2. So now I have y equals, and now I have 2 items, 8 and negative 4, that are both being divided by negative 2. Before I continue, I'm actually going to rewrite subtraction as adding a negative. Then I'll do my beans. 8 divided by negative 2 is negative 4, plus negative 4 divided by negative 2 would be positive 2x. So now I can identify the slope and the y-intercept. The slope is still going to be the coefficient of x, which in this case is positive 2. That's the number that's multiplying x, and the y-intercept is negative 4. Be careful in an example like this. A lot of people think the slope comes first because it's the first thing that you see here, but it's always the number that's multiplying x. So 2 is the slope, negative 4 is the y-intercept. So on this side, we're going to see 3 examples on how to graph using slope-intercept form that have a variety of different things. So here's our first example. First, you want to identify the slope, which is 5, and the y-intercept, which is negative 2. So of those 2 items, one of them is actually a point on the line, and that's the y-intercept. Slope tells you how steep a line is, but it doesn't tell you where that steepness occurs. But the y-intercept actually tells you where the line is going to hit the y-axis once we draw it. So this line that we're about to graph, we know will hit the y-axis at negative 2. So to graph that, I'm going to go down 2 on the y-axis and put a point. The thing that the slope tells me is it says how to get to the next point. Because if the slope is 5, then as a fraction, that would be 5 over 1. And if I use the formula rise over run, that says in order to get to the next point, I need to rise 5 from here, 1, 2, 3, 4, 5, and run 1, and then put a point. If I had room, I would put as many points as would fit. That's the only one that would fit, and now I'm going to connect with a line. And I would also draw arrows on the end, because this line could go on forever in both directions. On my next example, again I'm going to start by identifying the slope and the y-intercept. So my slope here would be negative 3, and my y-intercept would be 1. So this time, I'm going to start my graph up 1, because that's where the line that we're going to draw will cross the y-axis. The difference this time is with a slope of negative 3 as a fraction, that's negative 3 over 1. So I have rise and run. This time the rise is -3. So when we rise, we're actually going to go down. 1, 2, 3, and we're still going to run 1. And now I can plot other points that will fit, and I can even go backwards. So instead of going down and right, I can go up and back. And now I can connect with a line. This example is significant because in the original equation you can see that the slope is negative, and then if you look at the line, it's going downward from left to right. So the fact that it has a negative slope when you're done is a good thing. If you take a look at the first example that we did, the slope was a +5, and this line has a positive slope. So in the end, you just want to make sure that your lines are matching your expectations. So now let's try one more. The difference here is that the slope is already a fraction, but we're still going to identify slope as 1/2, and my y-intercept is 3. And so first I'm going to graph my y-intercept of 3 by going up 3 on the y-axis. Now since 1/2 is already a fraction, I'm just going to write it over here, rise over run. I don't have to make it into a fraction. I can just see that 1 matches up with the rise, 2 matches up with the run. So to get to my next point, I'm going to go up 1 over 2, rise 1, run 2, and then I can actually do some going backwards as well. And of course, I'm going to connect with a line and put arrows on both ends. And that's how you graph using slope-intercept form. If this had been a negative fraction, just something to think about, if the slope had been -1/2, let's say, then that negative sign would only go with the rise. It would only go with a -1. So you'd be going down 1, right 2, down 1, right 2, and you can kind of see how that would make a negatively sloped line when you're done. So just be careful with something like that. One other factor to consider when graphing these 3 examples right here is that all of them were already in slope-intercept form because they all had y isolated. And that if you're being asked to graph using slope-intercept form and y is not isolated, that would actually be your first objective.